This video is about application for the second derivative. Application 1 for second derivative is to classify the stationary points. After you get the roots for first derivative equal to 0, you will try to get the second derivative. After you plug in and then check if the second derivative is greater than 0, that means concave up, which means you will get the local minimum point. If you plug into the second derivative get less than 0, that's concave down, so you will get local maximum. If the second derivative equal to 0 and the first derivative equal to 0, both equal to 0, it could be the stationary inflection point. You have to check, do you have the concavity change at this point? If there is the concavity changes at this root, then you will get the stationary inflection point. For the second derivative, another application is to figure out whether the point is a point of inflection. So first of all, you will get the first and the second derivative. We will set up the second derivative equal to 0 to find the roots. Then you got to do neighbor value test. If there's a sign change for second derivative, then this point will be the point of inflection. If the first derivative equal to 0, we call this is a stationary inflection point. If the first derivative not equal to 0, you call this is a non-stationary inflection point. If no sign change for the second derivative, this point is not a point of inflection. Let's go to guided practice 1. Consider f of x equals this. Find the first derivative and the second derivative. So we're working for a, the first derivative, you will get 12x to the third power minus 48x squared plus 48x, then minus 0, you don't have to write down. For the second derivative, we will do the derivative of the first derivative. You will get the 36x squared minus 96x plus 48. For the B, find all stationary points. Use the second derivative to classify them. For the stationary points, we will make the first derivative equal to 0, which means 12x third power minus 48x squared plus 48x equal to 0. So we will take the common factor is 12x. You will get the x squared minus 4x plus 4 equal to 0. Then keep factoring, you will get the 12x, x minus 2 times x minus 2 equal to 0. Therefore, your x1 equal to 0, x2 equals to 2. This is the first step. Your second step, you will working on the y1. When we plug a 0 to the original function, you will get negative 9. For the y2, when we plug in 2 to the original function, you will get 7. Therefore, we got 2 points, 0, negative 9, and 2, 7. So for third step, we got to use the second derivative to classify the stationary points. We plug 0 into the second derivative. You will get 36 0 squared minus 96 0 plus 48 equals 48. Since this is greater than 0, so 0, negative 9 is a local minimum point. Because greater than 0, that means concave up. That's why you have a minimum point. For second derivative of 2, we plug in 36 2 squared minus 96, here's 2, plus 48 equals, you will get 0 here. Since the first derivative of 2, you get 0, and then the second derivative of 2, you also get 0. You still cannot decide this is a stationary inflection point unless you do the neighbor value test for this 2. So we have here, this is a 2, 2 plus 0.1 and 2 minus 0.1. This will be x, this will be double prime of x. So here's 0. Check the sign by neighbor value test. By graphing calculator, you will get this is a negative, here's a positive. Since there's a sign change for the second derivative at x equals 2, therefore, this 2, 7 is a stationary inflection point. When you decide a point is a point of inflection or not, you need to check the sign change at that point for the second derivative function. If there is a sign change, then it is a point of inflection. If not, it's not point of inflection. Now let's go to the second question. F of x equals this. And find the first derivative and a second derivative. So you will get the f prime of x equals negative 12 for x to the third power minus 24 x squared. For the second derivative, you will get negative 36 x squared minus 48 x. Let's go to B. Find all stationary points and use the second derivative to classify. So first step, you will set up the first derivative equal to 0. So negative 12x third power minus 24x squared equal to 0. We take a common factor that is negative 12 for x squared. You will get the x plus 2 equal to 0. So x1 equal to 0 because negative 12x squared equal to 0, which means x equal to 0. Then x2 equals negative 2. Then second step, you will get y1. You will plug 0 to the original function. You will get the negative 3, 0 fourth power minus 8, 0 third power plus 2. You will get 2. For the y2, you will get negative 3, negative 2 fourth power minus 8, negative 2 to the third power plus 2 equals 18 here. So you get these 2 points. You will get the 0, 2 and negative 2, 18. Then third step, you will work out the second derivative of 0. we plug in here, you will get the negative 36 0 squared minus 48 times 0. You will get 0. Since the first derivative gets 0 and then the second derivative gets 0, so you need to check for the point of inflection. We will make a table here using the neighbor value test. This is x, here's a double prime of x. 0, 0. So 0 plus 0.1 and 0 minus 0.1. For this table, you could see the sign change. Therefore, this 0, 2 is a stationary inflection point. Now let's check this point now. Let's label this is A. Now let's check f double prime of negative 2 equals. That equals negative 48 is less than 0, which means it's concave down. So this negative 2, 18 is a local maximum. Let's go to C. Find all the inflection points and justify. The points of inflection you will get by making the second derivative equal to 0. So we will set up negative 36x squared minus 48x equal to 0. You can use graphing calculator, get the roots directly, but I will show you by factoring to solve this equation. Common factor will be negative 12x. So you will get the 3x plus 4 equal to 0. Therefore, x1 equal to 0. For x2, you will get the negative 4 over 3. For B, we already figured out this is a stationary inflection point. Let's check for x2 equals negative 4 over 3. So we will draw this table. Here's x. This is a double prime of x. Negative 4 over 3. You will get 0. Negative 4 over 3 plus 0.1. Negative 4 over 3 minus 0.1. Since there is a sign change for the second derivative, so at x equals negative 4 over 3, there is a point of inflection. Now let's go to C, find all the inflection point and justify. How to find the inflection points? You need to make the second derivative equal to 0. So you will get the 36x squared minus 96x plus 48 equals 0. You can use graphing calculator, get the roots directly. I will show you use factoring to get the solutions. So common factor is 12. You will get the 3x squared minus 8x plus 4 equal to 0. So danger x, 12, negative 8, 3, 3. It will be negative 2 and negative 6. Reduce is negative 2, here's 1. So here's x, here's x. You will get 12 times 3x minus 2 and also x minus 2 equal to 0. x1 equals 2 over 3. For x2 equals 2. For B, we already figured out for x2 equals 2, it is a stationary inflection point. Now let's working on the x1. we need to make a table to check whether there is a sign change at 2/3 for second derivative. So you will get his 2/3. Here's 0. This is x second derivative of function. 2/3 plus 0.1 and 2/3 minus 0.1. When you put into graphing calculator, you could say there is a sign change at 2/3 for second derivative. So at x equals 2/3, there is a point of inflection.